in question are about APS-C size sensors versus full-frame sensors. And for photography, that's kind of important because it has to do with full-frame sensor size, which is equivalent to 35 millimeter film, the old Kodak rolls, you know, as it went on out. Boom, ba, ba, ba. As compared to a digital full sensor, which is not full frame, which is much smaller, usually about 1.5 times smaller. So it's where you get that term 1.5 crop factor. So what does all this mean? Well, the big question about what all this means is going to be explained pretty swiftly real quick. So first thing is, when you have a full frame sensor, you've got a nice camera, it's got a lens, and it has a focal length. We're going to use 50 millimeters as a general guide because it's going to be easy. And on a full frame sensor, what that's telling us is that there's some light that's coming in from our subject. And as that, let's actually erase those two that didn't look anything like what we want it to. And as that light comes in, it hits the sensor. When it hits the sensor, that sensor is a square. Well, actually it's a rectangle. But the light makes what's called an image circle, where the light just goes right around, and although this is not perfectly to scale, the point is that the circle just goes all the way around to the corners and makes sure that it covers the whole sensor. So that's the first thing we need to know about what's happening. So when we've got our subject here, let's take red, and we make our little guy, and we take a picture of him, he winds up on the sensor there, and we have a picture of our guy on a sensor. And on a full frame camera, this equivalent right here is just that. It's equivalent. 50 equals 50. When I talk about this 50, I'm talking about this focal length right here. It's all the same. On an APS-C size sensor, we've got some similar things happening. We've got our camera, we've got our lens, right? But we have a sensor that is smaller. If we go back, we'll remember that this sensor is 35 millimeters across. The APS-C sensor is 24 millimeters across. So it's smaller. And it's smaller by a ratio, and that ratio is actually 1.5. Some camera manufacturers are 1.3 crop factor, or some are 1.6 or 1.7, but for here, we're just going to keep things simple with 1.5. So let's say we've got a digital lens made for digital cameras with an APS-C size crop. What that means is that this 50 millimeter length is going to be different. But how can it be? We say, isn't it the same as the other 50? Isn't 50 50? Yes, 50 is 50 on a full frame camera. Over here, we're going to find out that by the time we get our happy light rays and they start coming in, and we've got a picture of our guy, the picture that ends up on that light circle is actually a different picture. Look at that, we only have part of him. Where did the other part go? Well, here's where the other part went. Because the sensor's smaller, they build it so that that light circle is a lot smaller as well. So when we've got our sensor, the light that's coming into it, that image circle, isn't coming in the same way as it was on this big full frame sensor. Remember, this was large enough to accommodate 35 millimeter sensor, and this light is only a 24 millimeter sensor. So the light circle, the image circle is different. Because the image circle is different, it appears to have a magnification. But there's no real magnification at all. That's just something that we're doing to ourselves. It just appears that way. Well, what magnification is that, since we talked about it? Since we said it's going to appear to be something, what is it? Well, let's go ahead and draw our happy little full frame sensor again. Here's our full frame sensor. Okay, we're going to draw it a little bit bigger so we can get in there. Remember, This is our full frame at 35 millimeters across, right? When we draw our happy guy from the image circle, when he comes in so that he can take up the whole frame. And that image circle roughly covers the frame like that. Just pretend it was really circular. But when we are on a APS-C size sensor or a crop sensor, we have a crop. So the same light is coming in, but it's focused differently. And because it's focused differently, the image circle is different. And now this image circle here is showing what appears to be a magnified area. It just looks like our subject, in this case, it just looks like he's magnified. Because on the full frame sensor, he appeared the correct size, right? Well, not really. Even though he looks like he's big here, there's no magnification that's happening. The lens that we used, remember, was that 50 millimeter lens. The difference was one lens was accommodating a full frame sensor and one lens was not, so they were built differently. So even though 50 equals 50, because the crop sensor is 1.5 times smaller than the full frame, it appears to have a magnification. So, what would that magnification be? Well, it would appear that this would be at 50 millimeters, and if we zoomed in, it would appear that this one would be at 75 millimeters. But that's all an optical illusion for us. It's only because we think that it's actually a longer lens than it is. Lens still only had a focal length of 50 millimeters. One lens is designed to fit on full frame. At full frame, it's going to give a traditional aspect ratio. But here on our APS-C, the aspect ratio is a cropped factor of 1.9. And it gives the appearance of a larger or longer lens. It makes a 50 millimeter lens look like it's 75 millimeters. The reason that this is important is camera companies have taken advantage of this. One of the big advantages of using an APS-C size sensor is they say you can get longer zooms, which makes everybody happy because we all want to get longer zooms. Well, the reality is you're not getting longer zooms, you're just getting an apparently magnified sensor. But you're not even getting a magnified sensor, you're just getting a lens that has a different proportion. So we're just comparing two different things. Really, a full frame sensor equals an apple. And an APS-C equals an orange. They're both fruit, but they taste different.